My presentation will be on series circuits, Kirchhoff's voltage law, and voltage divider. I'm going to begin this with series circuits. Now, in a series circuit, it is taught that the current runs through the entire circuit without any change. So, current represented by I is the same. Now, the way that I remember this is that I think of a series circuit, instead of it being a square, I think of it as a circle, like a kid running in a circle. No matter what, that kid is running in that circle the same way throughout. The circle does not change at all. And that's how I remember for a series. Now, in a series, in order to be able to find your total resistance, all you have to do is add up your 2 or 3 or however many resistors you have. You have to add them together and you will find your total resistance. In this case, it's 38 plus 15, which equals 53 ohms. Now, from there, we move down. I put a note for myself here to remind myself current stays the same. Another hint towards myself where I know current stays the same is I look at the first letter in series. The first letter in series is S. And I associate S, because sometimes I get confused between parallel and series. So what I would do is I would go S equals sum of R and V, which is resistance and voltage, and S equals same I, which is the same current no matter what. It'll always be the same current in a closed loop series. So I move down, and in this case, from a series, we are taught how to find resistance, total resistance, without any resistance values. In class, you are taught as a student, you are taught from this table that you either divide voltage by resistance or voltage by current in order to get your wanted value. So, in this case, since I'm looking for R, I'm going to divide voltage by current. So, V divided by I. And in this case, voltage is 5, current is 3, and that comes out to, wow, how did I forget that? My bad. 1 second. Well, it comes out to 1.67 ohms as the total resistance. Now, the same applies when you're trying to find current. If I were to say that we don't know this, but we know this, I would go I equals voltage divided by R total, which is 5 divided by 1.67, which should equal out 3 amps. And that's how you would find current. Some other to better understand this, I would use the tips I said already in order to be able to memorize what a series is and what the difference is from that and a parallel. Because I as a student would get confused between series and parallel depending on if the current stayed the same or the current changed, depending on what the series looked like. So that's what I do for series circuit. Now, for Kirchhoff's voltage law, it's a simple law, but it is hard to remember at times, especially when you're crunching for an exam. So, Kirchhoff's voltage law is that no matter what, the rises and falls, the rises in voltage, and falls in voltage will equal 0, will equal a sum of 0. So if you are running this current, running this circuit, current is running this way, through here, all the way through here, and coming all the way back. Each one of these currents, each one of these voltages will subtract off from the original. So we'll go E minus V1 minus V2, and it will equal 0. Now, for myself and for other students who get confused on this, when I look at Kirchhoff's voltage law, I write at the top of the paper equals 0, especially in series. It equals 0, 0 series. And it's plain and simple for this one. There's no better explanation for it other than it will always equal 0. If it doesn't equal 0, there's a problem. And you could change this around by saying, if you want to find, V2 and you don't have V2 but you have E and V1, what you can do is, since this equals 0, you can go E minus V1 equals V2 and be able to substitute in the values and find the value of V2. And finally, so this is the voltage divider law. Not law, voltage divider. So volt divider. So for this one, if it ain't broke, don't fix it. So I just changed your numbers around. And so for this one, remember the triangle. I think to better understand it, I would always remember the triangle. I'd always write it at the top of your paper. Otherwise, you might forget. So for the voltage divider rule, remember, current is always the same. So series, current is same. Series, same I. Series, same I. SSI. So, for this one, in order to be able to find current, like we did in the first page, I is E1, because that's the total current. That's the total voltage. E1 divided by RT, which is the sum of all three of the resistors. So, from this, we have 8 plus 3 plus 7, so we have 18. So this would be, we have 18 ohms, so it'd be 20 volts over 18 ohms, which would equal out a current of 1.11 amps. Now this is the current throughout the entire... Hold on, I'm going to erase the K off of these, so that way. Let's go like this. This is the current throughout the entire circuit, no matter what. This does not change. It is the same. So, if we want, we have different voltages here for each resistor. Each voltage is going to be different depending on the resistance. So, with this current right here, we can go to V1 and we can put in the resistor value, which is 8 ohms. And we know from this right here that we multiply current times resistance to get voltage. So, we can go 1.11 times 8 ohms equals 8.88 volts. From there, we can also go to V2 and do the same step. We multiply again the resistance value of R2 and then the current, which is always the same, and we'll get the voltage. And then there's two data points, A and B. For these, we can add, they're in between voltage 2 and voltage 3. We can add these two together, so VAB equals V2 plus V3. Because in between these, voltage 1 value is not present. There's two different resistors. This resistor is not within this small series right here. So we would add these two together. So after I find V2, I would add these together and get the value. Tips to know is that, remember, current is always the same, no matter what. And voltage varies between each resistor. But it will always, 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 always add into 0 because of Kirchhoff's voltage law. And that's voltage dividing.